Hello, welcome to another video. I suppose I should open up some things where I'm looking. I've got a few commits that I thought I should kind of go over. I wonder if I was still kind of doing that. I had to do a reboot, which is kind of annoying. It seems that every time I plug in a monitor, I need to reboot in order to get a video. Modern technology used to work fine, no issues. Super upgrades later. So what I want to do is I want to show something like this, and it will kind of show all the things that I've changed. So perhaps I can maybe make it a little smaller. The first thing that I did was some mouse things, and they're kind of hidden away in this little thing here, but I've done a few things. I've basically prettified the way that mouse events get shown. We now work out whether the mouse was down, so now we know whether we're dragging or not. And that's kind of useful in a few places. And now we also kind of say, hey, the child's requesting this mode and they're disabling this mode. Kind of useful, and same with the reporting, so we can kind of see what that is. And some of that is kind of just this kind of mess of thing. I feel like there was a thing that was kind of missed out of that, or maybe stuff happened in an earlier commit. So, in the printing of mouse, I kind of do a weird hacky thing that basically, if we're in default and we're released, then it's saying lose all the button information that's button done. We can kind of add on this other stuff. That's my read of the various docs and whatnot. It's a bit of a rabbit hole, this whole thing. So now we've got this. We kind of say where we're printing it for, rather than just the plain stuff. And we don't actually hear, so perhaps I'll kind of make those changes live as we speak. So we go to my project, and here we can go into bt.c, and we can go for writing event. And so I kind of want this, I guess, and maybe kind of that. I kind of want to get to the space actually though, so you kind of want to get that. As you know, that's kind of fine. So I'm yank to finding to you can't see a thing that I'm doing. Yank finding to there, and then here we can just kind of do a paste and paste, and here we also kind of need a this is kind of saying where it is, so we can just say mouse dot column mouse dot row, that is column, yeah, and then row where we're kind of showing it, so then it'll kind of show the XY. Cool, so they'll kind of go on its own commit later on, but that's what it is. Here, what did I do? I took away a stray new line that shouldn't have been there. Here we also do a thing in RxVT, we kind of lose all the button information there, but we lose it a lot more than this. We lose all the modifiers and whatnot. And that was my read, and maybe play around with what I've kind of experimented with. In fact, I have a little tool which perhaps needs compiling mouse.c -o mouse, and then we can kind of do things. That doesn't do anything. Still got that on, but yeah. So what we can do is say we can get the drag in URXV, and we can maybe see that. And I think in mouse.c, I'll just do a hex dump, and this one we can just point out that and do that same command, and then we'll be slightly a bit less. So that's kind of interesting that we got interesting. Right, so maybe that URXVT parsing isn't quite right. I'm not too sure, but we can work that out. But yeah, so I made this kind of mouse event thing that you can say only care about the click events, and now the click only kind of only works in its standalone terminal. So at the moment we're running. So I wonder if I can just go like this, and it does that. Nah, that still kind of opens up that, but we can see my little hacks, and then pretty much this stuff here, and we can just do that. And then if we open up again and then source, so this one is not in tmux, doesn't have a green bar down the bottom. We'll see. So if I go click in here, it does work in this, and I wonder if you are VT. Yeah, this also gives quite wacky numbers, which could be for reason, but yeah, we'll get to them. I suppose like it's kind of looks the same as, nah, it doesn't. It kind of comes as that. So yeah, I feel we need to reread the docs maybe, or check that out. But I've got a little tool that I can kind of check that a bit better. So here, when I run the application, so I have made some changes. So if we go to here, yes, and we can just get that and tell me what is wrong. So it doesn't like that, all right. Oh no, it just didn't have. Can we just get this and something like that, and then you'll like it. Then I just forgot to do that before. Cool. So if we kind of do this, and now if we click somewhere, the mouse will go, and it won't crash as soon as we move the mouse, which was a issue in the other time. Yesterday, I believe it was for me. Right, so basically we comment that out. We could remove that, but it means that like it kind of gets captured, and then when we process key, which we're processing every key at the moment, we'll work up to why in the patch that does that. But basically, if we don't have a child, we'll check whether it's like a moving or release, or it's a not left button click. So pretty much anything doesn't work. But I mean, this kind of shows room for maybe we could detect scrolls and whatnot, and then do something based on that. And you can see applications could be growing out of that. And like it's separated from the VT library and then rewinked out in some manner. Anyhow, sticking to the track. So this, when we're click tracking, I was ignoring every movement, but we actually want to have some movement because scrolls come through as mouse movement when you ask for all movement. It's just what happens on my terminal. And I think I tried a couple of others. I try others for some things, but not other things, so I don't know how fully featured this is, but I feel it does kind of work in a lot of places. There's differences. I'll get you there. But yeah, so the button right is kind of, it goes left, middle, right, and then after that you have none, I believe, and then after that you have wheels, like wheel, scroll up and down and left and right and whatnot. And because of that, we kind of want to just say it isn't a movement and then kind of send it through anyhow. We also do another check here that if it's kind of greater than that, where yeah, so we now kind of move that goalpost to include the wheels, so it does actually send through easy. When we're doing the press release mode, we kind of do the same thing. We allow wheels to go through. And we're doing the drag mode. Now we kind of check that was down and then kind of send through if it is a drag, if the was down was not set. If the was down was not set, but then this button now is not none. So basically, if we've got a button down now, then it's kind of the first of a drag instruction. So this kind of picks up that. Here there was this little thing, and here is where the was down kind of stuff happened. So basically, we set it to whether it was down already, and then if it was a mouse event, because like we might hold down the mouse and then start playing around with the keyboard, and then release the mouse, and that whole time is kind of a drag. And yeah, I don't know. That's just how it is. But yeah, if it was a mouse, then we can kind of update it to be, well, not if it was a release or the button was a scroll wheel. And if that was the case, then it is not down. And then after we clear it, we set that field again. So it will be set even for keyboard events because it's not a union. A union would actually break in this case because, yeah, you kind of, we got state that's kind of used everywhere, which potentially that could be a little clearer. Hard to know. So here we are kind of processing a key if we got back something that was not a key. If that makes sense. I feel like that's not quite right. Because it'll start off being none. Hard to know. That's like in the mode where you're not running a child underneath it. We've got kind of two modes at the moment, which is an interesting thing because what's the goal? We've got a few goals, but yeah. So This is kind of allowing you to have multiple private instructions. So the escape open square bracket or close square bracket, open one. Then a question mark. You can have multiple parameters separated by semicolon. Before you could not. So it's basically just shoving a for loop around existing stuff. It looks a little gross in the if because it's kind of spread out a little, but that's in essence all it's doing. We did seem to get 2 more functions in the mix, but I'll probably came out of the last one. I'll tell you that. So now instead of just passing the first, we pass none and then hit or does that thing. Here's some code to do UTF encoding and decoding. So I just read what it needs to do and kind of worked it out. So you kind of need to, you have a UTF, you have like a code point, and so that code point it's 0 to whatever you want it to be. What you want to do is break it into like chunks of 4 nibbles, and so each of these nibbles will get a letter. That's kind of what it's called in whatever spec I read. I was kind of printing it out, but commented. Here we do a bit of assertion, so it's like a bit different code pattern to earlier, but yeah, I kind of put this in just to test it out. And this is kind of what happens on each of the codes. So basically it checks for a marker, like basically I can support up to this, I can support up to this, or I can support a bunch more now, and now I can support a bunch more. And then like if it's too big, I'm like, don't know what to do. And in each of these things, we kind of say it's got I guess you could say a sentinel value at the front, and then it will kind of encode some of the nibbles in some way. So it can kind of fit a few nibbles, depending on what that sentinel at the front is. And then here, if you've got 2 bytes, you kind of have to split it out. So the first byte will have C0, whereas before it was just 0. So it's basically setting the top 2 bits. And then here we can fit in a bit of extra stuff. And then the second byte, and any other second byte, so you'll see here these all have 80s for the second and further, will have just the first bit set, but not the second bit. So you can kind of detect you're in the middle of a UTF string, and you can kind of step back until you get something where more than just that bit is set. And the number of bits kind of determines how many bytes you have in it. So say if you're on the 3rd byte of a 4 byte thing, you have to go back 3, but then you can tell that there's a 4th byte, because you might not know whether you're on the end. If you keep on going off the end, you might read just random data, and that random data might have the top bit set. So you shouldn't do that. You should always step back. But this code just kind of packages all up in a 4-bit byte, 4-byte integer. But yeah, so here we have that encoding. For the next one, we kind of add 1 more bit, so that's got 3 bits, and then a 0, and then can't encode as much stuff in. And then these 2 just have HO. Easy. And these were like the codes I had before, which was like maybe a bit better to read or a bit not. But then I thought I'd break it out into the letters, which makes it easier if you're reading kind of alongside the spec. But yeah, hard to know. And then this one has 4 bits set, but then a 0 at the end, and then some other stuff. Yeah, and then we kind of return that. And like, technically we should do like an assertion that this other stuff doesn't clobber the sentinel values, but it is what it is. That's potentially a bit too pedantic. So this one is decoding whatever thing you get. So you basically get 4 bytes into something and you want to decode it, and you'll just decode it into a code point. So how you do this is you have these same letters, so these are going to be your nibbles that you build up, and you kind of build it out of so if you don't have that top bit set, you know you're in just a 1 byte thing, and so that is the byte. You get those 2 nibbles that you need, and then that's that. Otherwise, you're in some kind of multi-byte thing, and you detect whether you detect whether you're like 1 byte, 2 byte, 3 byte, 4 byte, etc. And that's kind of like doing this and like shifting it down a little and getting the next ones. And like there's some stuff you can deduplicate, which I've done, which makes it look maybe a bit weirder, but otherwise it might look a little stranger if you kind of do it a little bit. And that kind of means that like here you're like the 4 byte, then the 3 byte, then the 2 byte, and it's kind of interesting. But it worked. And then you just return whatever it is, and we got some assertions at the end that this shouldn't happen. Like basically, it should just be a nibble. Shouldn't have anything more than a nibble. Print out what we're about to return. Easy peasy. Here's like a little routine to print out a code point. So you give it a code point, and it'll just encode it and like print out just the number of bytes it needs to print out, and then kind of return the number of bytes it printed out. Here's a little test to show that it kind of does it. So take in a code, print out that code, then like kind of encode it, and then decode it, and then get that, and then check that that is the same. It doesn't actually check that the printing prints out the right stuff. I could do that by like changing this. What it is an fprintf. You could do an fprintf to a there is I've lost the thing for it, and it's like a if string open or something. Yes, you can do that. Was that the one I wanted? Open mem string. There was another that you have to kind of give the oh no, that's I see. Yeah. So you can have these 2 functions where you kind of give it a pointer to a pointer. So it will, whenever you flush, I believe, whenever you flush or close, these 2 values will be accurate based on what has been written or read from. I mean, I assume you can do reading and it can kind of do things. And like this can kind of shift around when you're in a buffer, but this is potentially good. And then we free the buffer at the end. And there was also fmem open. Fmem open. This is when you know the size. Yeah, so if you have a buffer of a particular size. Anyhow, with those, with the open mem stream, you could open a mem stream, print to it, and then get the mem stream, read it back, and then decode that, and then check that it is the same, which I could potentially add to, but I'm probably not, because I'm not focusing on this, but it is old code that I've committed up. This was just a little main test, which loops through all of the numbers that it can and runs that little test on it. And that's how I know that it works. And none printed that after I fixed everything up. That's actually if I give a code. Yeah, so if I give a code, it'll run just for that code. Otherwise, it'll print for all of them. Cool, easy. Back to the VT stuff. So did a little commit that added cursor styles. So here's some styles that there were. The first four, well, up to underline, is in the spec. These vertical bars are not, but I've seen that they exist and I use them in some of my projects, so I've added it in. You'll see here there's a none and a blink block, and they're both kind of blinking block, and later on there's a check for both of those, and they are like kind of a weird 2 default value. It is what it is. And I kind of do it like this because I assign a number that is directly to this and some checks around it. So this is a CSI space function. It's when the CSI team go to space and do some crime scene investigating. That'd be cool. I'll probably watch that. They'll just be on the spaceships the whole time. It'd be interesting. But yeah, anyhow, new little CSI style. So we've got all these enums. So this is because I use this style, so X macro style, you call it. I've kind of adapted it and added some other stuff to it, but it means you can kind of just have one line and kind of build out a lot of things that would be many lines and a lot of duplicated code. So you just do this and copy pasting and kind of making the right things, and your compiler tells you when you're wrong, and so we put it in the structure, just a cursor style, and when we set it, we set it, and here we've got that. If we have a parameter of 0, we set it to 1 because that's what it is, and then we set it to that. After checking that, we know what it is. And I mean, people could reach that. It's kind of a weird unreachable, because you could just ask for a weird cursor that doesn't exist. My thing doesn't do it, so like perhaps that could be unimplemented, but this does the trick. Now I wonder if this should make it dirty. I think not, because this is kind of how I'm setting the cursor style, and like, yeah, it's just done because it's set to my TTY. Cool. So this is space dispatch. This is kind of a copy paste off other stuff, which would be kind of cool. I don't think you can do it with C macros, but it would be kind of cool if you could kind of have a macro that kind of duplicates all of this based on like a name, and then you can just kind of define CSI space, define CSI question mark or whatever they all are, and it'll kind of just dump this out. You probably couldn't have these static assert, but the rest of it is just to copy paste with some strings. But yeah, so this was done in the if the first character is so it's when you collect it, it's not a parameter. The first character of the CSI string could be a question mark or less than, and they're like private ranges. The space is not, so the space I kind of put it at its own. It kind of looks a little weird next to the privates, but it is what it is. And then they will kind of dispatch that. So I've added some bright colors, basically offset this all by a little to make everything line up, and then we have attribute bright for everything. It's 90 and 100 but it's the same 0 to 7 in each range. So that. And then we kind of have a, when we're drawing the gutters, we'll set the attribute of the gutter lines to which we can potentially see if we do something like this. You'll see it kind of reset it, but if we kind of do go through 3, that one, do something like that, and then just go high. Now it kind of shows the cursor and the gutter line, the actual colors. Interesting, it showed this one as the cursor color. So this is the 100 marker, but it is kind of interesting. And then when it resets, it resets. So to do that, it kind of needs to know what color this is, which is, I don't know what it is. So I kind of add all these things in, and then that does another thing to kind of copy all the attributes into the right place. So this is now adding a cursor report. So this is when you want to know like where you are. You can do like a I can even see what it is. It's a CSI and then an N, which is the cursor report, and then we send this, and then it should tell me that's where I am. And I've printed that out, and you'll see I've got the gutter. So this is kind of my thing. And I've printed out a response, and this is the response that you're meant to kind of give. And so you're meant to give the cursor wherever it is. So this one said it was on 5. So it was on line 5, and it was on column 1. So it kind of swaps the X and the Y weirdly. But this is how it is. And it was at 1 there because it was kind of starting to print that. If we do something like high, it will go to 3. And so it should have 7 because we're on line 7 of inside the thing, and 3 because where this whole thing started printing was on 3. So added that. That's used in a few places, and that's used so you know where like the cursor is. Sometimes that's needed. Added page up and down keys. So now I can push page up and page down, and it knows it is a key. Here is an interesting one. So I've added some numpad keys. Nothing maps to them, but I've added them in. Now, the reason why nothing maps to them is because every terminal I try, even like the base Linux kernel, like single user mode type thing, like go to that, and in that it's a different code to if I run it in like ST, or if I run it in just plain ST without tmux, if I run it within screen, if I run it within like Getty or not Getty or Kitty and the Ghosty and UARX VT, GNOME terminal, which is basically VT terminal, and Xterm I think I tried as well, and like they all just kind of have different codes that will happen if you push a numpad key, which I'm not sure how to push on this little keyboard. So you can get the full information from EVDev, which if you have the access, you can listen to any key press in the entire system. So that's like, being dev ed dev, dev input, and then like all of these. So if I can read them, then I can kind of see what inputs there are. And like, is there like ls input, ls uh there's like some way to kind of pretty print what all these are, but I forget the command off the top of my head because it's not that important. But what is important is the fact that I am in you'll have to type that. I'm in the group input, so I'll be able to read all of these. And not everyone always is though. I didn't actually want to do that. That was my diff one, wasn't it? That was kind of interesting because, yeah, I don't know. I think we need to jump a little more. Those are the things. Yeah, styles, all that. Right. Page up and page down. Yeah, so that's what I was kind of talking was this numpad stuff. So KV EVDev, you can read it. X11, if you have a window, so like you would have to have a window which like a console or terminal emulator like this or any of the ones that I was kind of listing before, that is popping up in X window so it can listen to events while that's focused. EVDev, you don't know what's focused, you just get them all. So it's not really that useful in an emulator type thing. But yeah, the terminal you also couldn't get it, and like these kind of also did other things. So like for example, if we if we go cat minus v and I lean over here and do these things, you'll see here this is like 3 and 9 on the keypad, and that is the same as page up and down on the keypad. And because of that other patch, that would be detected as up and down, page up and down. The 5 and 6 of the tooled variety. So I can't really reliably work out whether something is this, but for the sake of completeness, I guess I'll put in this DECKPAM and DECKPNM, which stands for like keyboard program and application mode and numeric mode. Basically, when you push this key, if you're in this mode, it will send through some code, and if you're in this mode, then it'll just send through the number 1, 2, 3, 4, whatever it is. And it starts off in numeric mode. Cool, I can implement this as like the action if these keys ever get hooked up, which they might in maybe a different kind of thing. So this is where I kind of had some like unimplemented, and the reason why I'm doing this is because I kind of want to run applications like BTOP or HTOP or something, or even just top. Maybe they're not relying on this, but also stuff like Vim and my own stuff. Some of them might use that. Well, none of mine actually use this, but Vim, I think, sends these codes, so we gotta handle it. Vim's been around a long time. So we just do our little tiny enum for this. So we've only got 2 things. It will start off with 0, so that's good. I'm kind of wrapping everything in braces just so we know where everything is. Little comments say nothing actually does that. Here we check if it's one of the numpad stuff, then cool, we'll do something. If we're in numeric mode, then if it's one of these special ones, we'll just output that special character. Potentially do this without the switch with like a ternary type thing, but otherwise, if it's not one of these, we just do the character 0 plus the difference between whatever type it is and the type of the 0. So basically, it'll work out which digit it is and we'll put in that digit as that. And if it's application mode, then that kind of follows a pattern, does like escape, then O, then either capital M if it's enter, or it's a range from L to Z, and that's based on whether it's a comma. So a comma is L, and if it's anything above a comma, and it kind of goes in the order, comma, minus, period, all the numbers. And if we got a different mode, probably corrupt memory or something, we'll do that. Got a flush at the end, and we had a little comment about that, which doesn't matter now. These OSC starts, I've just kind of put a little comment just to get past them because something calls them, and I'm not quite sure what to do with them just yet, but I'll perhaps get there when it kind of matters. I put in restore cursor. That's reasonably straightforward. So the docs say that if you don't have a cursor, you do kind of a few set things. I don't know how to do 2 of them because haven't implemented this origin mode thing and don't really do this GL and GR thing. So that doesn't really matter, but we can do this and that. But it doesn't free any of the cells. That kind of stays as is. If you did have a saved cursor, we just kind of copy it using just that kind of struct copy, which I believe kind of does what I want it to do. And then that kind of is used up, so we'll just clear it. Doesn't say whether you should do this, but I feel like you should. Once you save, you restore, you shouldn't be able to like restore lots. But I mean, you could just take out these 2 lines and just do that. That's that. I added in some logging for when you had like an SDR parameter. So basically it says you got an SDR parameter, it'll kind of print out what it is and then show what the attributes are. Then on top of that, I've also got a diff, which is, I don't know. So I've got like a few different options, and I think this is the option that I kind of want to go. So maybe I'll kind of post it out, but maybe with no X diff. And if we look at this, I'm basically taking away the notion of standard out and standard error from the client. The client still gets it, but the reason is most terminal applications kind of expect that your standard out or standard error or standard in are kind of connected to a TTY, and that TTY should also be the controlling TTY, and also it should be all the same TTY. So like I've tried there's a couple of patches, I think just 2. So I tried just one PTY, which is the one that I'm kind of going to do, which is what's kind of applied, I think, which is kind of just taking away the standard out, standard in. Easy. That does all that. And the whole magic. And I feel like this is safe because I've had this for a long time, that we kind of have an option to send standard error to VT. Haven't implemented it. This can be done elsewhere. Like when the child is created, you can be like, hey, is that option set? Yes, cool. I'll just duplicate standard error now rather than duplicating it to the TTY. So we don't need to do like a bunch of stuff now with the TTYs, but in the setup child, what we do instead of duping to those pipes, we just dupe to the TTY that was kind of given to us in the fork PTY. And the fork PTY does three things. It does a fork, it does a open PTY, and it does a something else. Can't do it there. Fork PTY. And a login login TTY. Yeah, I feel like I'm not sure if that last one kind of needed, but perhaps it was login TTY. Yeah, making the file script the controlling terminal for calling process. I wonder if I actually need those dupes if I'm using that. Quick text. I like doing these tests. So we have dupe 2. I wonder. So if we delete that and like, can we do a dot out, something like that here? And this kind of works. Cool. That I think we don't need to do because yeah, it is printing stuff to there. And like if I do a dot out without redirecting it, it prints stuff to the standard error. Easy. Cool. So that's that. And the other thing that I was kind of looking at was so we don't have to do those at all. We don't have to close anything because we don't have a pipe. We don't have to do that. So yeah, really all the magic is in the fork PCY, and I don't do anything around that. And I guess if I wanted an option, I have this argv, which for some reason I'm kind of, oh no, the argv is the argv of the child, but I could potentially also pass in an option to redirect to standard error or redirect to this file here. And this file here could be something that's like opened up in main if that option is kind of set like for standard error of child to this file here, which could be kind of useful, especially if say you're wanting to run my program, which writes to standard error quite prolifically. Cool. So because of that, we don't need to do child IOPS. Is that correct? No, so I still so I still have it. I think I did like a different patch at a different point. But yeah, so I do still have that. It's not complaining that I don't have it, but yeah, this is the other patch. Yeah, so this was the patch where we have 3 PTYs, but only one of them is controlling GTY, and that kind of had some other niceties. What I found was if we kind of open up things, if I did Control C, that would only work if the controlling TTY is standing in. If I opened up Vim, it currently crashes, but before it would complain that the output was not a terminal. So you kind of have to have it as a terminal, but now it crashes for other things. We can implement features. But yeah, so I also tried having 3 PCYs, so it kind of changes a few things. So we're not having a pipe, we don't have a RAM2, we just have a single file descriptor. And a few other things kind of have to change because of that. We that single win size, that's easy. Yeah, just a few things had to change. But the magic is really down in here where we call open PTY 3 times to basically get 3 PCYs. And then we also have to do this sets the ID to become the session leader. And then we also have to do this IOCCL to set the controlling TTY. And you do that on the input. If you did it on the error, then Vim would be happy, but then like control C will work and like you have to have it on the input. But anyhow, this patch wasn't going to be that was just something that I was trialing out. But I think like what I have is kind of what I want. I've got a few other things as well, but yeah, I think this is kind of what I want. So what I might do is add that up as a little patch. Not that one, not that. This and that, and that, and that, and that, and that, and that. Remove the notion of error splits for blind. And this one was kind of fixing it. Certain reports fixed up mouse read and static error. Cool. So what I kind of want to do now that we've gone this far, hour, I kind of want this to, as it's receiving input, so we're currently kind of receiving input, there's a few things that'll kind of make it crash. Like I could potentially make it crash here and like I don't know, is it when we do that? I don't know. Sometimes it crashes there, but like if we do something like that, like I don't know, it's being like real good. But I suppose I can. It's like doing it inside. Cool. So that crashed it. I would kind of like to know what crashed it. So I do have this whole thing running, and one of these things, I just want that. It crashed there, but I kind of want to visually see the frames that it's going through. Like, oh, I got this. I output this frame. Oh, I got this. I output this frame. Oh, I got this. I output this frame. So, what? Yeah. What I kind of want to do is make it so it's a bit of twofold. So I kind of want it to be able to replay a thing. So I guess it would be something like that, and that input dot then this we would probably want it to have like a process So I'm trying to think of a good input. Because you run into issues if you're trying to be pedantic, I guess. If you like this, you might have 1, 2, 3, and if we maybe change this to like you run that and it did the thing. We're not to see the output, I guess. How many arguments does it actually have? It's got one. That's not really counted as an argument. That's another. That's another. And this is just one whole thing. So if I were to say, put down here the exact same thing that I get, it's not actually the same because I just have the list of words, I guess. So I guess you would kind of have like a perhaps even something like this. It's like a little brush, but you could have something like this. You know, I think I'm trying to paint anything too much. I think I could just have something like this, and if you have, because I have it like by the argument, and if I have an argument with double quote in it, I could just do something like food, something like that, and it will kind of correct it and print it out like that in that form. I think that's kind of fine, and then when we kind of process that, we will kind of process it by space. If you hit a space, then cool, that's one argument. If you hit a quote, double quote character, go to the next character and then scan until you find the next double quote. But if you have a slash right before it, then skip over it and then kind of do that. Now, if you get that double quote, ignore it, but then kind of add on whatever's else, because you can have stuff like that, which like I don't know what that is. And afterwards, I kind of want input to be almost like at this time I did this, at this time I did this, at this time I did this. And that's kind of what I want to see. I don't know how to quite do it because, like, if we have lots of like, do I want something like that or something like that to say it was that many seconds delayed between or something, and then we would actually kind of sleep that, and then yeah, we might have keys like that. Perhaps like 1 second, I don't know. Maybe this can be like nanoseconds by default. And I don't know. You could probably have stuff like this, and it will kind of. I believe we've got a we have something like yeah, this function here where it kind of returns whatever it is, and don't do it for space. Yeah, and I think I've just spied a few issues. Let's maybe make that a little tinier. So we've already got this VT printing, so we can kind of print out a whatever, and it'll print it out to the stream. And so, like, if we have raw input, that can be presented as 0x AB co-oriented in that after a second, I guess. And like perhaps if you don't have a timing information, it's just defaulted to no wait. So it only kind of waits when it kind of gets there. And I feel like this is perhaps what I want. Perhaps just those two lines. And like these commas are just redundant now. Or are they? No, I think commas are needed because of the optional times. But yeah, so perhaps I want to go about first off writing this file, and then being able to replay from it. So we would probably have something like now it's kind of interesting because like when I'm saving it, I've also got all the frame information, and I don't have the frame information in this input .bin. But perhaps I also kind of want an initial state. Oh yeah, perhaps I either want a command or initial, and that can be some files. And this probably also wants to have a width or dimensions, so we know how big it is. So that can be width times height, I guess. And so perhaps we can have stuff like this, and that can also have timestamps, and we can kind of into these things. But then what is the thing that you need to track for? Winch. So this winch, what does it change to? So this probably needs to have like a width times right, and then whatever time. But yeah, and I kind of feel like you can then kind of interspace all of these kind of like that. Like perhaps that could then have the output show kind of side by side, and we can just hit output and blah blah blah. And then when we're kind of replaying, we kind of ignore that output when we're replaying, and we just replay up until a point, perhaps overriding that output. I like it. Cool.
So where do we start? I first want to do in setup IO. So we have stderr. We print to stderr a lot. And I think I want to have I want to do two. So is tty stderr. If this is the case, then I kind of want to have log file equals if open div null, and like sure, let's do that. Else log file equals stderr. And so I guess this can be the T log file. And then like pretty much every instance of stderr, I kind of want to change to VT log file. So log file doesn't actually exist at the moment, but we can make it. We can put that log file. So where were we down here? Perhaps I want to do a global replace of stderr with the t log file, and we'll do it globally, but we'll ask me to confirm. And what do I want to do in these? I think, yes, all of these I want to be to that log file. Not that. Right, so on restore IO, this is kind of closing off everything. I kind of want to take a note to, are we allowed to, we can break here because I haven't actually changed anything. So if we have log not equal the error, then we want to if close VT log file, and perhaps log file equal null. And like, what do you get if you if printf? What if you do this to null? Like, what if stream is null? Interesting. Because I feel like my printer, like the TTY, like it would always be the case. But perhaps that's just a kind of yeah, because it could be null from that. If the TTY TTY. We can kind of just do that, like return -1 or something like that. Cool. And then we can feel safe that it's kind of always set. And perhaps this. And like this can say it's null, and then that's going to be a log file. And in setup IO, that's kind of this code there. So I guess we don't have any args. So if we have a can we just do something like this? Doing a few things there. I don't know. So here we can have const star arg equals next arg. We have that, and like I don't know what if we just printf is here and arg. And maybe we can put some bars around it just so we know that it's there, and that perfect. We can just return value there, and so he'll kind of close off. Cool. So we are we not allowed that? On complete type diff VT. So when we are doing this, what makes it incomplete? Surely. We did that. That surely doesn't cue that up. Yeah, we close things right. We to there we have okie dokie. Is it because of this thing? No. Right, so huh. Is it because all yeah, it's because all of those were I think. Right, so in here. Yeah, so these need to be like the Jesus need to be after that. And then that's fine.
all it needed. Cool. So now because we've done that, I kind of want to have that open up, but can we, yeah, well, you are letting me do things. So if we go to here, and so now if I just kind of run things, it can detect an arg like that. So I guess the args I was normally doing in this here, so I guess I kind of want to do that, collect them all, and then like kind of stop at when my args kind of stop being known and only really want to do this like exec CBP. This exec CBP, that one, exec CBP. So if we have a P, it will search path. Makes it a little harder for me to check whether $600 doing this. Yeah. Open mem stream to f print eg to the code that buffer. Right, so when we get args, what we could do is work out if they're valid for us, and if they're not valid for us, then we just assume that they are part of the path. Like, what happens if I, like if I just kind of run this? I get like no feedback as to what kind of happened. What if I kind of do that and kind of see what happened? That's that. So we kind of get that exec CDP, no such file or directory. So that was in the child TTY. So that's see, it's like this issue here because we've already done the PTY, which is kind of dupes the original thing. I mean, like, it printed to the virtual terminal, so I think it's potentially all right. So, back to kind of where I was. Yeah. So if we have an arg which looks valid to us, so I guess if arg we might have stderr arg of, and this I kind of want to have perhaps like X macro type dealio. I'll write it out to start with. So what we want is it's SDRCMP of This is like a log file. Yeah, so if we have that, and if it is equal to that, and I care about cases, I think there. If that is the case, then we want actually next. Are we allowed to do that? Yeah, that's all right. So I would want to get another argument, and I would want to f open that for writing. Yeah, I think I just want to do that. And is that how I do f open? That sounds right, and it returns me a file. So here we would want to get VT and log file equals that. So that kind of means to me that here we want to check that if not VT log file. If we've already got a log file, then kind of keep it as is, do something like that. Right, so if that is the case, if not VT log file, might do if printf the error could not open for writing log file, and maybe we'll put it in quotes for writing, and then we can just pass in that out that we got. And if that happened, perhaps we can just return one here. So we had some usage error, I guess. Else, if it's the RCMP, and here we can have ARG, and here we can have. I kind of want to do NCNP. Hear me out. So here we want to do that and a length of 2. So if we have a random argument like that, I kind of want to say, I don't know what that is about. So this is invalid argument, and we can perhaps give it back to them. Invalid argument, and perhaps we can kind of print out the usage. So what is my usage? So if I had usage, I would probably want to have start program. I'll probably want to take it in the program. And so here, like, it kind of is now asking, what do I want out of this? So what I could do is define like VT options list. Is that kind of what I want? And then we can have like an X of like dash log file, and perhaps we can call this VT option log file, and it can have a string of that, and it could perhaps have a like an option to say like whether it takes another argument or not. So maybe args, it could have like
it has args after it. And perhaps this can be something like it could either be like, yeah, I think that's kind of what I want. So we can have that is the argument that it'll kind of be. And then, so the idea is this can kind of go there, and in here we would define x. So yeah, we would want to have like a so we'd have size t I equals 0, I is less than, and we're going to have a num options. Doesn't exist yet, but it will. So we will go through all of the options that will kind of be populated in this thing here. And then in here we will just want to get VT. So I guess I do want to kind of get it all kind of loaded up like this stuff here. So we're going to have this, and maybe we can do like s/cursor styles, and we can replace that with options, and then we can also do the same thing except do switched out of mode. So I want to do that, and then we can do that same thing. That didn't do what I want. I want to redo that, and then this I want to take off and S and S, and then it'll kind of do that. And then wherever we use this, I kind of want to do just those two. That's interesting on a different level. I wonder if that will kind of break things. We'll do the same thing there. And then I want to do that, and feel like I did it differently for other things. Cool. So then we search for the next thing that it kind of has. We'll do that. We'll do that. Cool. And that's the one that we're going to be using. So we want that, and we want that, and this we kind of want get that. Cool. So that's all the places that we kind of need to do that to basically define this. And I wonder if you can do that in that kind of order. And so that kind of means we now have this string long, and we can get a string long of the option. So if printf So we would have stderr, and like perhaps we want to pass in the stream that we want to give the usage of this to. I don't know. So we would give the usage of usage and then thing s, and so that's going to be our program, and then in that's going to be everything on that statement. Then on this we will have an fprintf of stream, and then here we're going to have a space, and then we're going to have like everything is going to be optional, really. And then here we will have, so we'll have that %s. And then we're going to kind of leave it a little hanging. And we allow, oh, we're different keyboard. We'll leave it a little bit hanging. So it now we need to kind of check whether that A, so we haven't kind of got that A. So if we kind of go back here, we have this option string long, which has all the options of that, but it's also got this A, which we don't really handle. And so I guess here we can we kind of need to do something before we do everything. So we'll have define A of, and that can just be kind of name like that, and undef A, and then define A of name should just be nothing. So that is roughly going to do that, and so this is option argument, and we'll just get the options list. So we'll just kind of make an array of all of these things. And so I also kind of want a way to get that out. So here we can, wherever it was up here, here we can also kind of get argument, and then we do that and argument like that, and like I guess might want to search for button and maybe change it to opt like that, and option dot slash bn, maybe do that same thing again, and then yeah, and then it's kind of annoying that it searches. Cool. So now we have this option argument thing. So we can have a const char star arg, and this is going to be equal VT option argument of whatever option that we currently have, which is just what we're enumerating. And if we have an argument, kind of print it out. Maybe we can just do that, and then we can close off this whole thing. So and so we'll just kind of close off this optional thing that
And then after everything, we would want to add in a new line. This is all the things that we do. Now, we can also extend this to be like, what is this actually doing? If that kind of makes sense. So like each of these things you could also pass in maybe a description and like set log file to path name provided and something like that. And over here you would kind of just have a similar thing. You would kind of need to define D separately. And then here you would kind of have that, and then you would do that, and then here you would maybe do that, and maybe we can call this a description because that is roughly what it is. And then here we can descriptions, and then do that same thing there, and the script and then that just kind of adds in that, and like, I mean, it might. Cool. So this has to be defined all the way, kind of up here. And I mean, it could be defined all the way up here. So like, this is what it's going to do, and cool. D redefined. So we already have D up there. So here we need to undef D first. Cool. So we're not allowed empty initializer braces. So that means the options list is currently, we don't have options long. So this was just string. And so we see it. So this is complaining because I mean, I get it. I kind of want, like, I have a sec make string. Can we just ignore the type limits? No, that doesn't feel right. I mean, I can kind of just do it with this and does the thing. Cool. We don't have a pointer at this stage, so we can kind of just do that. If this is the case down here, we probably want to continue after every kind of thing. And if we kind of get to this point here, we want to C minus minus. What do we actually pass to setup child? We just have that, so we can probably just have I mean, I was trying to do like weird things here, but what we can do is argv minus minus, and then v break, and maybe argc plus plus. Trying to paint a black shade here, and then we don't need that kind of thing. And this kind of thing here is also we can define it up here. With an S. I already have an S there. What do we use for? I think I want L for this, and I think I want that option string along. So wherever that is, there's this, but there's also a long version. So I want this, and we can try and change all the things that kind of need it. And then on the C, and then yeah, and I think that is roughly what I want. So this is now part of no, I'm not using that. I thought I was down with this. Option string long. So I want to get the long version of that. Cool. So option description is define never use. That's perfect. Cool. So so the description here, we don't actually print out the description. What we could do is kind of get all of these, and for each description, we can kind of do something like that, and then VT option description, and then I, and then do something like that, and and like if you have any options. As you know, that yeah, if you just have any options, then do this whole thing. Yeah. Think that's that. Cool. And then here we can add an S here, and that S is basically just going to be whatever happens here.
So we could perhaps even just kind of yoink that and maybe just do something like that. So we're never using it, but what we can do now is here we can, if we kind of just do this loop here again, and in here we have a define X of option to be case option, like that, and then define S of option to be, and this can be a brace statement of that. And this is really code, and then that can be code that we kind of presented just verbatim, and we'll continue at the end of this thing. So this isn't what I want. Because I'll be in a loop. We can do a break, and we can declare that, and then inside of this we're not wanting this. We want CMP arg. This could be option string long of opt. Yeah, this is it's not quite as clean as I kind of was thinking, but what we do is we have something like this, and this is going to be a VT option opt, and we can just call it opt, opt, and if that is the case, so if that whole thing was there, then we can break out of this, and that means that opt is now set. So if opt equals VT num options, then we probably want to break it out, but perhaps only after doing this. Otherwise we break out. Otherwise, we kind of have a option, so we can go switch opt, and here we can define the X of opt to be case opt. Like that opt is a different opt, if that kind of makes sense.
And then here we just do switch opt case, and then we do VT options list, and that's the switch case. And then we undef x, undef x, and then all that kind of doesn't need to be done. And like that does the thing. So basically it goes through, finds what option we have. If you don't have any option kind of parse from the list, then we check whether we were trying to do an option. If we do, we do that. And then we probably want to do this in usage, stderr, and then program, process program. And then that kind of makes me, we want to go up here and do this and do that. And that's potentially what I want to do. And perhaps one of my options. So, I mean, this should currently work. Right, so that doesn't handle that. Yeah, this one should never really kind of happen, but it wants me to do it. We're not allowed to do that. That's because we. So I think here we want to word pass parts, and this is going to be DECRC, but it's going to be appointed to that, and then we're going to have a const like a. Is that kind of what I want? So then we kind of can do all of this stuff inside of there, and then we can just go process R. We call it the process R. What are we doing? What do I call it? Parser. R. And then we can pass it. Well, we can pass it VT, and we can pass it IC, and we can pass it IV. Don't do that. I was about to do this silly thing. Do that first, and then do that, and then that should be able to kind of set what we want. And so this next arg thing, can get done in this whole thing. And so I guess program is only really needed in this. We're going to get the program first. We don't really care about it in there. So that's now getting done. We can VT process args. And then this can be the same thing. Right, so what does it want now? We're not allowed that, but what if we to that. This might return, so so that is the case. So we've got stuff there. So is that kind of what I want, and then it is that kind of what I want. And so I guess this does need to be indeed. I mean, perhaps it can be a boom, and then that return, and that can be false. And then when we do that, if not process I's, we just have that. Cool. So then we do that. Yes, so it should be in here. We never pass them that struct. No, it says VT, isn't it? VT star. VT. You need to pass them that. Yeah, I did. So now I want that. Cool. Right, so we've got a char const star star, so I think I need to just bring one of these stars to there, and that's what I want. And then this is return through. We successfully passed the options, and it should have kind of magic, and this I think needs to be like that. Which makes me think that this needs to kind of have that sort of treatment. Initialization that comes from Charlie. Right, so this we don't want. Hey, that looks like it works. So what I might do is just go print F and dot R, and we can just print out what it is, just to make sure that it's returning false. It'll kind of get us out. And that comes to be like yes. Endless loop if you get past that return false. Just have it in there as well. Cool. Perhaps this can just be that, just so we don't accidentally do things. So now if I do that, it should kind of get all the icons as needed. Cool. So if we do that, this setup charge should kick in from, so if we just do dash dash, well, we get a usage option. Valid argument, perfect. Invalid argument, so this should kind of print out to there. Otherwise, this kind of prints out a lovely usage thing. So invalid argument, this is how you use it. You can do log file, and if you have argument, so where were we actually doing that usage? So if you have an argument, I want to have a space before it. So yeah, we can have that, and then you can have a log file of the file name. And if you do that, so like if we do temp2, it should kind of open something. It's not logging everything there, but it should have kind of made a file. Hasn't printed anything to it, but yeah, that's kind of what I wanted this thing to do. So I don't want to change that standard error. This one, no. This one, right, we're killing a child. It's kind of a log message. I'll put it to my log. This is all log stuff. So at a certain point, you should have a kind of log where you can kind of do things. Now the P error, I realize, won't actually do it to the right point. No, but yes and yes. Bunch of like, big change that does it everywhere, and I'll have to make sure to never print to standard error. But yeah, so this should kind of get all the logs written to a thing. So it kind of seems like I now just don't have to redirect my output, but in reality, I didn't want to change that actually. So at this point, we should have a log file. Same there. And from there, we can have some better logging. This did, yeah, it did. We never actually print it out. Now this, we don't actually have access to the log file at that point, so no. But we should at this point, I feel. We don't actually have it at all in this stuff. Not at all there. And I want to keep that as is. And then, yeah, I'll print that log to there. Cool. So I think I might want to kind of log this to a thing. So if I kind of do that, cool. Stuff isn't quite compiling. That is because we just have that. But if I kind of just run that, so this is now hopefully made a bunch of stuff in the log file. Ooh. And so this kind of means that we can do stuff like this. And I'll run two of my applications and ignore the weird coloring color. But now it should have created a temp2 with a bunch of stuff, and it should have also created a temp3 with a bunch of stuff. So let's add that up. So got an option for adding the thing. This is kind of adding all the option stuff. Option. This is fixing some string of the cursor style, but also adding the string and also this, what have we done? We kind of shifted the code because it needed to be done. So we deleted for, well, we put it there, but we kind of removed it from there. And here we just had a lot of things with log file instead of what it was. I'll slip this one in here, but it's kind of just really fixing stuff up. But yeah, so this is that all just standard stuff. Nothing to see here. So that's if we're doing that. Yeah, that's cool. This is good. That's just usage and whatnot, and then kind of do that instead, and then do that. Yeah, cool. So git commit and log file option, and I'll just kind of add UTF-8 twist. Cool. So what you can kind of do from that is you can now make another option, and perhaps I'll in fact make the first option, which anyway, this can be option help, and this could take help. It could do something like that. I think that's what we need to do. And then show usage for your ignition. This so there. And in here we can just simply go usage and stderr and program, which I believe we have in the scope that it has there. And I think I'll do a return false, because that's kind of happening in this process args. So we'll get help, and then we'll do it. And in here, if we are returning, yeah, so I've spotted a bug. This return 1 should probably be return false. So if we couldn't open the log file. But yeah, now we have a help as well. So if I go out dash dash, it'll kind of show, cool, you actually have a help option. If I run help, it'll kind of just do that. And if I try and run something else, it'll not actually take into account that. If I have it in a different order, it will kind of complain about the lock first. Cool, so that's kind of how easy it is to add an option now. Git commit add dash dash help. So the whole point of this, got like 2 hours in now, spend an hour kind of showing what the code is. My whole idea is I want to be able to output into this file here in this kind of format, and then also kind of replay from it. So I guess for that, you would probably have like a replay and a record. I actually wonder whether I might split that into a separate video, just because got to this point and it took a bit of time, but so we kind of have a clean slate, and it's nice and easy to get started with the kind of replay and restoring. But yeah, I think I'll leave it there. That's a nice little feat of what we can do. So we should still be able to. So now we can do this log file temp2, and we can just go bash -I, and it'll magically work. And cool stuff kind of works. And we can probably even like run a code editor. Nah, that didn't work. That's like running it inside of itself. So what if we just try and run that? It doesn't actually like that. I feel like I've broken something somewhere along the way. Yeah, interesting. Because this had the yeah, remove notion of standing error split. That did that thing. I thought that would have. The other thing is I can get color in my alias. But yeah, this is interesting. Oh, is that because I'm like kind of too small? Yeah, so that's just because I'm too small. And so now we can kind of do things like that, and they kind of close. We can't run beat top, but we can kind of look at that temp file and work out why. There's a control function that I need to do. That's what it is. Cool. So I think I'll leave that at that for this video, but I think I'll come back reasonably soon to do the next one, which is replay restore. Well, like store and replay. Don't know, but yeah, we'll kind of print out stuff like this. And I wonder if you're replaying, if there's no command, you probably want to have, yeah, hard to know. I'll leave that puzzle. For now, thanks for watching, and let me know what you think. And if you're interested in other stuff, I've got plenty of other stuff, and I might come back to it because, yeah, I come back to things from time to time. For now, thanks for watching, and I'll see you next time.